Hello and welcome again. So our today's topic is network model. This is basically the second chapter of data communication book. So in this chapter, we will discuss about two different model. One is OSI model, another one is TCP/IP. Before move on to the discussion, we just want to discuss few things. So as we all know that a network is a combination of hardware and software that sends data from one location to another location. So a hardware consists of a physical equipment that carries signal from one point to another point, and a software is consisting of an instruction set that make possible that services that we expect from the network. So basically, when we want to send data from one sender to receiver, so from a sender side or a receiver side, we basically need something combination of hardware and software so that a communication is smooth and it is flawless. So how a communication can happen? So let us see an analogy that how two friend is communicated by writing a letter. So this is we talked about the task is called layered task. Why it is layered? Because this task is not happened or not performed in a single way. It actually needs multiple processes that we can that a sender can send the data from one end to another end. So the concept of layer, we everyday actually use the concept of layer. So here we actually present an example. So let us consider two friends who communicate through a postal email, not email, it's postal email. That is traditional letter writing, right? So the process of sending a letter to a friend would be very complex if there is no service available from the post office. So just imagine that there is no post office between a sender and receiver. Then how can a friend write a letter and send this letter to his friend and expecting an answer of this letter? So let us see the next slide. So how or what the task actually involved by sending a letter? So from the left, it is a sender, and from right, it is a receiver. So first one is what you will do when you want to send a letter to your friend. First, you need to need a piece of paper and a pen and to write something, right? So from the sender side, a letter is written, put in an envelope and dropped into the mailbox. This is the first thing. The second one is the letter is carried from the mailbox to a post office, right? The third one is letter is delivered to a carrier by the post office, and then the post office actually sort it out by analyzing the address that is mentioned in the envelope and then carried this letter from one district to another district. This is a physical movement. But from the receiver side, what will happen? First, the letter is delivered from the carrier to the post office, and then letter is carried from the post office to the mailbox of an individual receiver. Then letter is picked up, remove the envelope, and then read. So this is the task, or we can say this is a layered task between the sender and receiver when they want to send a letter. So what are the involved? What are the tasks involved? First one, at the sender side, there are three different layers. First one is higher layer, then middle layer, and the lower layer. Higher layer means a sender from a sender side, a sender is written. On the contrary, from the receiver, the letter is picked up and read. So write and read is the higher layer. The middle layer is letter is carried from mailbox to post office. On the other side, it is post office to the mailbox. So that is the middle layer. And the lower layer is what? Lower layer is the physical transfer of data from one place to another place. So this is basically an analogy or a conceptual understanding of a task that involve multiple layers when we perform to achieve a specific goal. So main intention is sending data from a sender to a receiver, right? So first of all, to do this kind of layer task, we introduce a OSI model. So OSI model is not a de facto standard, it is a de jure standard. There is worldwide accepted, but it is not openly used. But we need to actually learn or understand the every layer of the OSI model because these layers involve the task of these layers involve is exactly similar with the task in the other model, which we actually called is TCP/IP. We will discuss it later on. So first talked about the OSI model. So in OSI model, it is established in 1947. The International Standard Organization ISO is a multinational body dedicated to a worldwide agreement on international standard. So a ISO standard that cover all aspects of the network communication is called OSI. So it was first introduced in 1970. So there are two different terms. One is OSI, another one is ISO. So ISO is organization, whereas OSI is a model. So let me discuss about the layer of the OSI model. So yeah, as you can see, there are seven different layers in the OSI model. And at the very lower level, this one is physical layer. Then it is a bottom-up approach. First one is physical, then data link, then network, transport, session, presentation, and application layer. So if you want to send a letter to your friend, you need to follow these seven layers. And by each of the layer, you cannot ignore or you cannot jump from one layer to another layer. You need to follow the rules and regulation each of the layer, and then you can send data from you to your friend. So now let us discuss about the functionalities of each of the layers. So this is the OSI model structure. As you can see from the bottom, physical, data link, and network layer. There is we actually called the hardware supported or network supported layer, by which a sender can send data to the destination by through a peering process. That means when you are sitting four people in a row, sorry, in a column, then first one, or if first sender is send or want to send the data to the fourth one, then how it will be sent? First one actually pass the data to the second one, then second one pass the data to third one, then third one actually pass the data to the destination, right? This is actually called hopping by multi-hopping concept. And from the top, it is called user support layer, transport, session, presentation, and application. These four layers is actually called user support layer. So first of all, the physical layer. So as you see, the data is received from the data link layer, because data link layer is right upper layer of the physical one. So data is received from the data link layer, and as you see, data is actually converted into the binary, and these binary data is physically transferred from a sender to the receiver end, right? And there is a transmission medium, and in the transmission medium, you see the signal, the data is converted into a signal, then it is transferred. So we cannot actually pass binary 0101 by a cable to transfer the data, right? It is not possible. So we need to convert this binary data into a signal, whether it is analog or digital. After the conversion, we can actually transfer the data, right? So let us see now the functionalities of the physical layer. So first one is the representation of bit. As we actually see from the figure, the binary 01, it is the representation of the data. For example, I want to send a song to my friend. So this song is first converted or encoded into a binary data. So the physical layer basically represents the binary bit. Then second one is physical layer ensure the data rate. So it basically defines the rate of transmission, which is the number of bit per second. That how fast a sender can send the data to the receiver. So this data rate is actually defined by the physical layer. Then synchronization, which is very important. For example, a sender want to send a data, and each of the bit should be synchronized with each other. For example, first the transferred bit is 0, then 1. So it should be synchronized. First 0 will be communicated, then 1 will be communicated. It should not be happen first 1, then 0, then data will be changed. So every bit should be synchronized. Then physical layer should be provided an interface to the devices so that they can communicate. For example, in our laptop or desktop, there is a physical LAN port, right? This is the interface between you and the server there by which you are communicated, right? So physical layer ensure this interface so that we can communicate. Then physical layer also ensure the line configuration. Line configuration means what? As we actually understand from our previous lecture, it is point to point or a multi-point. So physical layer make sure that your configuration is either point to point or multi-point. Physical layer also deal with the topologies. So it also mentions whether your communication is in which topology, either mesh, star, ring, or bus. And finally, physical layer also consider about the transmission mode, whether your communication is simplex, half duplex, or full duplex. It is also deal with the baseband and broadband transmission. So this is all about the functionalities of the physical layer. So now move on to the data link layer. So from where data is received by the data link layer, it is received from the network layer, because network layer is the upper layer of the data link layer. So you can see there are two different things added into the data. One is H2 and T2. 2 means the second layer, that means data link layer, and H means header and T means trailer. So which is basically incorporated in the data link layer, and this is the only layer where header and trailer is added. So how data is communicated through the data link layer? So let us see the functionalities. First one is frame. So the data link layer divide the stream of bits that is received, that is actually sent to the physical layer, binary 0 and 1. So data link layer receive the data from the network layer, and it is actually framed by a manageable data units. So this division of stream of bits is done by the data link layer. For example, it actually received a bulk amount of data from the network layer, but it is divided the data into a manageable data size. This manageable data unit is called framing. So the main responsibility of the data link layer is to create or generate a frame. Second one is physical addressing. So if a frame needs to transfer from one place to another place, this frame needs to have a address. And this address is called the physical address, or as we all know that this physical address is MAC address. The third functionality of the data link layer is the flow control. So as we know, flow control mechanism is to avoid the fast transmission. For example, I have the capability to send 5 Mbps data, but my receiver is actually have the capability to receive 10 Mbps data, which is not possible for me to send because my capacity is 5 Mbps and the receiver capacity is 10 Mbps. But data link layer makes sure that the speed between the sender and the receiver should be in balance so that they can actually prevent the traffic jam between whatever we said, the more traffic that can be generated if the speed is not synchronized. So flow control, by flow control, data link layer makes sure that the sender and receiver speed can be in a similar position so that data can be transferred smoothly. Another functionality of the data link layer is error control. So in error control, we actually need there is a trailer and a header you actually seen from the picture. So at the trailer, we actually add the trailer at the end of the frame and duplicate of frame and the problem of the generation and problem of the transmission that can be detected by the error control mechanism. So it is a very much important feature for this layer. And final functionality of this layer is access control. And this is actually for the security purpose. For example, I am sending a letter to my friend, but which is not intended to receive by his parents. So it should not be received by the other person. So by access control, we can ensure that the data is received to the appropriate receiver. So as you see, there is a hope to hope delivery. As I discussed, the lower three layer, physical data link and network layer, they are actually communicating through hope. For example, they are not throwing the packet into the internet. They are sending the packet to its nearest next hop. Then next hop, next hop. By this way, the data is sent to the destination. Another layer we discuss here is called network layer. So network layer receive data from the transport layer and send to the data to the data link layer, right? So here you see only header is here, H3, but there is no trailer. So trailer is only added in the data link layer. So what are the functionalities of the network layer? The main functionalities of the network layer is to make a packet of the data. And then it translates logical addresses into a physical addresses. Then that physical address is concerned with the circuit message or packet switching as it is the functionality of the data link layer. So the network layer actually talks about or translate the data logical addressing, which we all know logical addressing is IP addressing, right? Another thing that network layers do actually determine the path by which a sender can send the data to the receiver. For example, if I want to go from Shukrabad to Motijil, a network layer will define the path for us. For example, first we need to go to the science laboratory. Then from the left, we need to go to the Shahbag, then go to the Matsya Bhavan, then go to Gulistan, then go to Motijil. Right? This is the path that is defined by the network layer, and a packet that need to transmit from Shukrabad to Motijil must follow this path. And main responsibility of the network layer is providing the logical address and also providing the routing or route to a packet so that a packet can follow and reach to the destination. And also a network layer can break the larger packet into a smaller unit of size so that it can be easily transferred. So this is how it works. It is also a hopping picture, just network layer is added here. Then we talked about the transport layer. So here you see the transport layer also received the data from the session layer and transfer the data to the network layer. So here you can see data is actually divided into different segments, right? So now let us discuss about the functionality. So transport layer basically is a process-to-process delivery of the entire message to to a process of a sender to a process of the receiver. So other than that, it is actually have several functionalities. First one is service point addressing. So as a service point addressing, it actually identifies the port by which a sender is sending data to the receiver. Then segmentation and reassembly, which is a very important feature for the transport layer. So if you want to send a larger data size, so it actually depend whether your device can send data or not. For example, you are using 5 Mbps internet, which indicates you can send 5 MB data per second, right? For example, you have a 10 MB data which need to transfer, but your capacity is 5 MB. But then how you can actually send data, send this 10 MB data by using 5 Mbps line. Is it possible? Yes, it is. So your system actually logically divide the data by 5 Mbps each, then send each segment into the network. So this is the segmentation feature of transport layer. It actually breaks the larger data. Then this individual unit is transferred to the internet. So this individual unit actually sending this individual unit depends on two different connections. One is connectionless protocol, another one is connection oriented. If it is connection oriented, then these smaller chunks actually maintain the sequence. For example, first division, then second, then third, then fourth. But if the protocol or if the system uses connectionless protocol, is actually not following any kind of hierarchy. For example, in the first time, it actually send the first chunk of the data, then after that it actually send the fifth chunk of data. So it is not logically maintained. So flow control is also here for the transport layer, as we understand from the data link layer, the same functionality for the transport layer here. Another one is error control, the same as data link layer. But the point is here, uh, why we actually need to do the error control in two different layers. As we actually did the error control in the data link layer, then why should we need another error control in the transport layer? So this is a question for you. I think you will find the answer if you read the book and if you understand the concept properly. So this is the structure of process to process delivery. So here you see there are a lot of process in a machine. So you can send one particular process from one particular process to the another process of the destination machine via internet. So this is not a hopping delivery. You can actually transfer the data in the internet. So this is not following any kind of hopping principle. Now let us talk about the session layer. So session layer receive data from the presentation layer and actually transfer data to the transport layer. So what session layer will do? Session layer will actually have few tasks. The main responsible is dialog control and synchronization and also the token management. So what is dialog control? Dialog control means before sending the data, two stations can communicate with each other that how data will be transferred, either simplex, half duplex, or full duplex. So based on this communication, data is transferred. Then synchronization. Synchronization means, for example, it actually allows process to add checkpoints, which are considered as a synchronization points into the stream of data. So, for example, if a system is sending a file of 800 pages, adding checkpoint every other 50 pages is recommended to ensure that 50 pages unit is successfully received and acknowledged. It is benefit because if the connectivity is lost or, for example, there is no electricity there, so you can ensure that your first 50 page is received or not. If it is not received, you can resume the data, rather receiving a larger amount of page sizes. So this is basically a resume support. If your connection have a problem, then you can resume your communication from that point of time, not from the very beginning. So this is also called the synchronization, and this feature is maintained by the session layer. So now let us discuss about presentation layer. So in the presentation layer, data is received from the application layer and it is transferred to the session layer. So what are the main functionalities of presentation layer? So the main functionalities of the presentation layer are translation, encryption, and compression. So as we all know, if we are browsing a Chinese website from the Bangladeshi domain. So, and Chinese website is actually written in the China language, right? Chinese language. So it is not possible to read from our side, right? So we need a service that is called translation, which actually translate these data into our native language. So in the internet, our native language is English, right? So before the transmission, we need to ensure that the character and number that should be changeable so that we can translate the data. So it actually provides the interoperability between the different computers using different encoding methods. Chinese companies or Chinese website using Chinese encoding, whereas we are using different encoding method. So a translation service can actually provide an excellent feature so that we can translate different languages or different languages data so that we can easily understand or easily send. Then the encryption. This is a feature for security purpose. So when we send the data, it is not sent by a plain text. Data is encrypted so that intruder or a thief in between the sender and receiver cannot actually read what we have written or what we have transferred. This is called the encryption, and presentation layer is providing this service. And final one is compression. So a data compression, the best example is Facebook. You have uploaded a very nice photograph of 10 MB. But after that, when you download, after it is uploading, you when you download the data, it actually download with, for example, 200 KB size. So it is automatically compressed. Why it is compressed? Because to save the space, right? So when we send audio, video data or text data, we need to actually save the space, or we need to cope up the transmission speed what we are using. So that we need to compress our data, and it is actually automatic compression, not like that we are converting the data into a smaller size then send. It is a automatic compression that provides the number of bits in a lower level so that we can transfer the data from sender to receiver in smooth and flawlessly, right? So this compression technique actually provided by the presentation layer. And the last layer of the OSI model is called application layer. So here, where the application layer can receive the data, it is from the user. So all kind of user application is actually is actually the responsibility of the application layer, right? So if we see the functionalities, so what we see first one is mail service. So email that we are currently using is actually the service of a application layer. Then network virtual terminal, then we can use directory service, we can use file transfer, we can use remote access, which is network virtual terminal, as you see. So everything, all kind of user services provided by the application layers, right? So if you can summarize the different activity of the different layers. So first one is physical layer. What physical layer transmit individual bit over a medium by providing a mechanical and electrical specification, right? Then the data link layer, what is the responsibility? The main responsibility of the data link layer was to make a frame and hope-to-hope delivery. And the network layer, it actually provides the logical addresses and the path by which a data can send. And the transport layer is basically depend on process-to-process delivery, and it also provides the segmentation and also reassembly. The session layer actually provide establish and manage and terminate the individual session. What presentation layer will do? Presentation layer actually provide the translation, encryption, and the compression services. And finally, the application layer. What application layer does? Application layer can give us any kind of support or any kind of user need it can fulfill. So these are the 7 layers of the OSI model. And the task that is involved in the OSI model is very much important. We cannot ignore any one of the layer while sending a data from sender to receiver, and you can even jump. So you can start from the application layer to a physical layer, then transfer to the data to the receiver, and receiver will also follow the same 7 layers while receiving the data. Okay, so this is all about the content of our today's lecture. So I will highly recommend everyone to read the data communication book. Remember one thing, this lecture is from the 4th edition of our book, and highly recommend to exercise the question that is provided at the end of the chapter. And you need to follow and you need to learn every point that we discussed here, and also relate the questions that is given in the exercise sessions, right? So if you have any problem or if you have any questions, so you can write in the forum that is provided in the BLC, so that we can discuss. Also, you can write down your points so that we can discuss in our live class. Okay, so that is all about today. So as I actually have written here, so you can go through the exercises at the end of the chapter and note that we are following the fourth edition of book. Okay, so this is the exception. So thank you very much for your patience hearing and hope to see you again in another lecture. Thank you very much.